Hi, welcome to Nomis Academy. In this video, we'll be dealing with problems involving geometric progression. So, geometric progression, problems involving geometric progression. So, let's solve some example. Example number one. Example number one says the first term of a GP is 3. The first term of a GP is 3, and the fifth term is 48, and the fifth term is 48. Now the question is asking that we should find the common ratio. Find the common ratio. So what will I do? Solution. To find the common ratio, let us first of all tell the formula of the fifth term. So the fifth term of GP, is equals to A R5 minus 1, right? And the fifth term we have is 48. The fifth term has been given to be 48. So 48 is equals to, remember that our A is the first term, and the first term has been given to be 3. So that will be 3 multiplied by the common ratio, which we are looking for. We don't know R. 5 minus 1 is 4, because we have fifth term. 5 minus 1, so that's fifth term. So we have 48 equals to 3 times r raised to the power of 4. So what we do next here is to divide both sides by 3. When we divide both sides by 3, we are left with r raised to the power of 4 equals to 48 raised to divided by 3. So r raised to the power of 4 is equals to, when we divide 48 by 3, 3 here 1, 3 here 1, 3 in 18 will be 6, so that will be 16. So r raised to the power of 4 is equals to 16. So what we're doing now is to find 4 roots both sides. 4 roots both sides. So the 4 roots this side and the 4 roots this side. So this cancel this. So r is equal to 4 roots 2 times 2 times 2 times 2. 2 times 2, 4 times 2, 8 times 2, 16. So I'll have 16. So r is equals to 4 roots 2 raised to the power of 4. So this cancel this. My r, the value of r common ratio is just 2. So the common ratio is 2. It's as simple as that. Let's take on the second example. Example number 2. Example number 2. Example number 2 says the first term of a GP. The first term of a GP, the first term of a GP is twice its common ratio. Is twice its common ratio. Find the sum of the first two terms. Find the sum of the first two terms. If the sum to infinity is 8, if the sum to infinity is 8, I know seeing this question, you're already feeling like this could be complicated, but when we sort it out one after the other, you'll definitely get to see that it's simple. So let's get into the solution. The first term of a GP is twice its common ratio. So if I'm listing the GP now, the first term is 2R. The first term is 2R. So that is A. So A is equals to 2R. Now find the sum of the first two terms if the sum to infinity is 8. So if the sum to infinity is 8, that means the sum to infinity exists and that R is less than 1. So if R is less than 1, I'm getting to get an idea from what I've learned previously now. So R is less than 1. So let's get to sum to infinity. Remember the formula to calculate sum to infinity? Sum to infinity is A all over 1 minus R, right? So sum to infinity has been given to be 8. So that is 8 equals to A. A is now 2R. So all over 1 minus R, so which is equals to 2R all over 1 minus R. So since 8 over 1 is equals to 2R all over 1 minus R. So I can cross multiply so that I will have 8 open bracket that is multiplied by 1 minus R close bracket equals to 2R. So if I open this bracket, I will have 8 times 1 to be 8 minus 8 times R to be 8R equals to 2R. So collect like terms, we have 8 equals to 2R plus 8R. So this is minus 8. When it comes to this, that become plus. So 8 is equal to 10R. So since 8 is equal to 10R, what then is the value of R? Divide both sides by 10. So that makes 8 over 10 is equals to 10R over 10. So 10 cancel 10. So I can tell that R is equals to 8 over 10. To reduce to the lowest term, R is equals to 4 over 5. So now I've gotten the value of A, I've gotten the value of R. So find the sum of the first two terms. Find the sum of the first two terms. So if I'll get the value, so I'll say S2, the sum to the first two terms is equals to A, the first term, open brackets. Now I have an idea that for the sum to infinity to exist, R is less than 1. Then I'll just say 1 minus R raised to the power of n close brackets all over 1 minus R. So what is A? The value of the first term. Let's go back. The value of the first term A is 2R. And now that I've gotten R to be 4 over 5, so that tells that A is equals to, so recall that A is equals to 2R. And now that R is equals to 4 over 5, so I can boldly tell that A is equals to 2 times 4 over 5, and that is 8 over 5. So very good. So let's keep that by the side. So we now have our A to be 8 over 5, so this will be 8 over 5, open bracket 1 minus, what is our R? 4 over 5. So 4 over 5. And what is our n now? 2. Because we are looking for the sum of the first two terms. So 2. So generally we will now close bracket. All over 1 now. Over 1. Abi. Minus the R is 4 over 5. So we need to just simplify the entirety of this. So this becomes 8 over 5, open bracket 1 minus, so square, this would become 16 over 25, right? 16 over 25, close bracket. So divide by Here my LCM is 5 all over 1 divided by 5 divided by 1 is 5. 5 times 1 is 5. Minus 5 divided by 5 is 1. 1 times 4 is 4. So this becomes 8 over 5. Open bracket. Here the LCM is 25. So that if you subtract 1 minus 16 over 25, you will have 9 over 25 without wasting our time. 9 over 25. All over here we have 1 all over 5, right? 1 all over 5. So let's take it to the next page and simplify it. 8 over 5 multiplied by, so now we are left with 8 over 5 multiplied by 9 over 25. 9 over 25 divide by 1 over 5. Divide by 1 over 5. So this is what we are left with to find the sum of the two terms, right? So this becomes 8 over 5 multiplied by 9 over 25 multiplied by this turn over to be 5 over 1. So I can simply say 5 cancel 5 here. So I'm left with 8 times 9. 8 times 9 is 72 and 25 times 1 is 25. So that's our final answer. This is an improper fraction. You may want to change it to a mixed fraction. So that will be 2 whole number 22 all over 25. And that is the sum of the first two terms of the GP. I believe you understood everything we did in this video. Take your time to go through them again, get the processes installed in your memory, and solve more questions on geometric progression. Bye bye. See you in the next video.